Between the structure and mechanical properties of this metallic material, there are close ties. Then, when we are at room temperature, this grain of metal, it is thinner. The better, the better. Then if the grain is thicker, that just doesn't work. Say if the grains are coarse, then we normalize it with some heat treatment tools or temper. Go and lower this one with the coarse grain. That is to say, when 1 unit of our area, the larger the grain boundary area, that's due to the increase in grain boundary. The resistance to dislocation movement. Do not make this intensity hardness. It's getting higher at the same time, under the same amount of deformation. The finer the grains of the metal, the deformation between it becomes more and more even. The stress concentration is getting smaller if the grains are coarse. Stress is also high. Sometimes often, especially when we are sawing, crack and blow. That makes this plastic toughness better. Refine energy enhancement. But an atomic arrangement at that grain boundary, it's also rather chaotic. Make its melting point low, also prone to corrosion. When we do some cold molding on this metal, when deforming, we'll refine this grain. Elongated energy. The density of dislocation also increases. That makes this intensity. Hardness increases. For example, our pure iron, that's 80% deformed. This can transform the, look at the intensity. That's about 180 megapascals from the original. We can go up to 500 megapascals. But his plastic toughness, corrosion resistance has declined and produce all kinds of this opposite sex. Even if there is no intention to increase this craftsmanship, when our metallic materials are made of plastic solution or hardness, when composed of brittle and hard compounds, this is what's called second phase reinforcement. Its effect mainly depends on some form of that compound. The network-like distribution of compounds. Decrease in strength and plasticity. If spherical, the granularity makes this toughness cutting reinforcement. That raises. This is mainly to reduce the degree of hard force concentration, and a fundamental component of the solid solution, an isolation effect, such as a dispersed distribution on the substrate, blocking the movement of a dislocation, and the one who gets in the way of going through heating, then its strength and hardness will increase. The plastic toughness decreases slightly or does not decrease. That's called diffusion reinforcement. It is distributed on the substrate in a sheet shape. Strength and hardness increase. The plastic toughness also decreases. And that tells you something about the structure between the three of them. There are some causal relationships that influence each other. So we're going to stop there for the moment. If you like me, please follow me. Thanks. Goodbye.